Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another Computer Science 9618 lecture for AS level, and today we are going to start our discussion on section 8.2 Database Management Systems or DBMS. DBMS is a software package which can be used to create, edit, open, save and manage databases. All DBMS have some common features, which are that they allow the creation of databases and tables, they allow the management of databases and tables, they have inbuilt security measures, they have a developer's console, there is a query builder and multiple views. They allow you to view the data inside that is stored in the tables or in the database in multiple views or in multiple forms, such as you can view them in as forms, or you can view them as reports, as well as they allow you to apply access levels. How does a DBMS address the limitations of the flat file system? A DBMS addresses the following issues which are found in flat file system. The first one being data redundancy. By applying normalization and storing data in multiple tables, duplication of data is reduced. Then data inconsistency. By storing most of the data items once only, data is always consistent, and as all applications view the same data, its integrity is protected almost entirely. When data is consistent, its integrity also improves. Data dependency. Data is not reliant on the structure provided by the application, but is rather managed by the DBMS. Any fields or tables added to a database will not affect any applications that aren't using them, as each application only has access to its required fields or tables, so no matter what changes you do to the database, it would not cause any problems for the database to be connected to a certain software application and be handled by it. Information is more easily available in a form that is not dependent on the structure of the data and the application being used. A DBMS usually includes facilities to query the data stored using a defined query language or a query by example facility. DBMS approach. A DBMS uses a well-structured approach to manage, organize and maintain data. Predefined data structures can also be used to set up and create database. Entry of data, storage, alteration and deletion of data is managed by the DBMS. Then we have a data dictionary. As well as storing the data itself, a database also stores metadata, which is the data about the data. This is stored in the data dictionary and includes the name of all the tables, the column names for all the tables or the attribute names, the data types for all columns in each table, data constraints or validation rules within the table, for example where a field allows a null value and where it isn't allowed. As you can see, this is a list of all the fields in the table and these are their data types. Then this column would at times contains the validation rules. This improves the integrity of the data, ensuring its accuracy, completeness and consistency. Hence, a DBMS in these ways eliminates the problems or at least reduces them to a very minimum level which are present in flat file systems. Data modeling. Data modeling can be conducted visually using a database management system's inbuilt modeling feature and is an important feature of a DBMS. It is the overview of a database structure which models the problem or the situation by using methods such as ER diagrams, which are independent of any particular DBMS. This is an example of an ERD diagram that is created by using a DBMS software, or you can say this is simply a model of the database where you can see there are obviously two tables. See, this symbol denotes that this is a table, year group and users, and in the year group table we have ID and name, two fields, whereas in the users table we have 1 2 3 4 5 fields or 5 attributes: the ID, the username, email, age and year group ID. And as you can see, ID is primary key in this table and it is acting as foreign key over here, year group ID, and as you can see it is having a one to many relationship. One ID, year group ID, can have multiple users. Database schema. A database schema is the skeleton structure that represents the logical view of the entire database. It defines how the data is organized and how the relations among them are associated. It formulates all the constraints that are to be applied on the data. This basically means validation rules. A database schema can be divided broadly into two categories: the physical database schema and the logical database schema. The physical database schema pertains to the actual storage of data and its form of storage, like files, indices, etc. It defines how the data would be stored on a secondary storage such as the hard drive or an SSD, whereas the logical schema defines all the logical constraints or the validations or verification rules that need to be applied on the data stored. It defines tables, views, integrity constraints, validations, etc. This is a logical schema and this is the physical. This is basically a diagram that shows database schema. See, first of all, in the basic layer we have the physical schema, like there's a hard drive or an SSD where the data is physically stored. Then the logical schema says that there's a table by the name of student which has these three attributes, and it can be viewed in three different ways. What are those ways? They are not well defined over here in this diagram, and you are not really supposed to go in much detail, but just remember there can be multiple views in a typical DBMS software. Relational database includes a number of inbuilt security features as compared to flat file. There is authentication through usernames and passwords. You can allot your employees usernames and password to access the database, whereas it cannot be applied in a flat file system. Access rights and levels specify what changes users can make to the tables. Do they have a read or write or append or delete access or not? Backup automation features. Your database is automatically backed up. Obviously, if you have turned on this feature and if you have connected it to a server, that is. Then we have the ability to encrypt data, so that even if somebody gets a hold of it, they are unable to read it. Transaction logging for auditing purposes. Then we have ensuring database consistency through transactional integrity. These are all the features in a relational database that makes it better than the flat file system. These are all security features. Next, we have the software tools which can be found in DBMS. Again, we are not talking about a special kind of DBMS. We are just talking about the common features which are usually found in DBMS systems or softwares. There are three types of interfaces that the DBMS provides. First is the user interface. This interface is designed for the end user. This is used to input and view high control data using user access levels, so that they can only view and edit data related to their account or for which they have the proper authentication or permission. And this is also known as form view in most of the DBMS softwares. The user is only presented with a form like this. They don't know the actual database behind it. They don't know if there are more attributes in the actual table or not. They can only enter the data which they view on screen or added it to a certain level. Then we have the administrator interface. The administrator interface is designed to allow a great amount of access and functionality, such as editing, deleting, inserting tuples or rows or records and attributes or columns or fields. Then the user interface, without the need to know SQL queries. Basically, the administrator interface is the kind of drag and drop back end access to the actual database table. It would show you all the field names and their attributes as well as all the data saved in it. Somebody with the administrator interface access or the admin access would have all of these rights to their account. They can edit the existing data, they can delete any rows or fields, they can insert new records and as well as create new fields as well, and they can do it with a graphical user interface with the help of buttons and menus on screen. They do not need to know any sort of coding for that. Lastly, we have the developer interface. Access to the developer interface allows detailed inspection of the database content and metadata to be performed mainly through the use of custom crafted SQL queries rather than query by example grid that can be executed within the developer interface. So basically over here, this is the absolute backend where everything would be shown to you in form of the actual code, and over here you can write SQL queries of your liking to manipulate the database. Each query is processed and executed by a query processor. As you can see, this is how the developer interface looks like. Then we have the query processor. The query processor takes the query text passed to it by other modules in the DBMS, parse the data and translates it and executes it in an appropriate manner. It consists of two things, DDL and DML. DDL stands for data definition language and DML stands for data manipulation language. Also, it has a compiler. Basically, it consists of two things, a DDL or data definition language interpreter, a DML compiler or data manipulation language compiler, and the third thing is a query evaluation engine. It basically consists of three things in total. We are talking about the query processor over here, a DDL interpreter, that is a data definition language interpreter, a DML compiler or the data manipulation language compiler, and the third thing is a query evaluation engine. DDL queries such as create and drop are passed to the DDL interpreter, which then reads or modifies the content of the data dictionary. DML queries such as select and insert are passed to the DML compiler. These queries are compiled, optimized and then executed by the query engine. So basically there are two types of SQL queries, the DDL queries and the DML queries. DDL queries are dealt by a DDL interpreter and they end up modifying the data dictionary, which is the metadata of the database. Basically, if you are creating a new table or you are inserting new fields into a table, then you would need to run DDL queries, whereas if you are simply extracting data from the table or you are inserting new rows or records or tuples when existing table, then you would use DML queries. These queries will be given to or passed on to a DML compiler, which is going to parse them or translate them, and then they would be given to the query engine that would finally execute them, hence producing the result the user desired onto the screen. That is everything that you need to know for section 8.2. I hope you have understood everything. By the way, the diagram on the last slide, you don't need to remember that. It was just for your understanding. And if you have any confusions or questions, you can write them in the comments below. I'll definitely respond as soon as I can. Secondly, if you have not subscribed to my channel already, please do so and share it with your friends. Lastly, if you need a hard copy of these notes or you need the study bundle for O-levels or IGCSE Computer Science, or you need the study notes for IGCSE or O-level physics, or you need the study pack for AS-Level Computer Science, you can order them all or whichever you want by using the form link given in the description below. I'll see you guys in the next lecture and we'll inshallah wind up section 8.3, completing all the topics for paper 1. Till then, take care. Allah Hafiz.